Hello, geometry scholars. We're going to be doing skill 4.5, which is on triangle congruence theorems. And this skill is meant to kind of give you the big picture of triangle proofs and sort of mapping out our overarching goals. So in this skill, you're not going to see a proof, but you're going to kind of see the roadmap of like how to do a proof, if that makes sense. All right, so the essential question that we have in triangle proofs is quite simply, why are these triangles congruent to each other? And just as a recap here, congruent means same shape, same size. So I could ask an elementary schooler, I could say, you know, do these triangles look the same? So we want to move from they look the same to the sides are congruent. And we can even get more specific, and we could say that AB is congruent to LM because they have one tick mark. And we could say that AC and LK are congruent. And we can also say that BC and MK are congruent. And we could say that the triangles are congruent. So I could say that triangle ACB is congruent to triangle LKM by side, side, side. So this is kind of what proof level thinking looks like. And what we're going to kind of be building in this video is how to kind of develop the sort of thesis statements for why triangles are congruent that kind of give us the roadmap of the evidence that we need. So obviously SSS stands for side, side, side. All right, so let's actually talk about ways to prove triangles congruent. So the first way is just by having that all the corresponding sides are congruent. So in essence, what that means is my triangles have three sides that are marked or can be easily marked. And that is side, side, side. And we even can just kind of label the picture. So that's S, S, S. All right, side angle side is next. And in essence, with the side angle side, we want to be thinking in kind of this situation that, and I'm just going to kind of actually type this out, that two sides are congruent. Or two corresponding sides are congruent. And the angle between them. So if I'm going to kind of like draw a picture here, I'm going to draw a side and then kind of an angle between the sides here. And likewise, on this triangle, I do the same thing. And this spells side, angle, side. All right, and then angle, side, angle is two corresponding angles are congruent. And the side between them. So what that means is maybe I have an angle that's congruent and another angle that's congruent to the corresponding ones in the triangle. And the side that is between the two angles is congruent. So that spells A, S, A, and that stands for ASA. And then for angle side, this is one where people do get a little bit confused with the ASA, but on this one, you have two corresponding angles are congruent and a side not between them. So in other words, if I were to draw a picture of that situation, maybe I have an angle and another angle, and then a side that is not between those two angles. And that's why it's called AAS. A, S. And then last but not least is HL. And this is only for right triangles. If the hypotenuses are congruent and one corresponding leg. So what that means is it's a right triangle. So that's one thing we know for sure. And we have to have a hypotenuse and a leg. And that's why it's called HL. And the nickname for this theorem is hypotenuse leg theorem. All right. So please pause the video here and take a picture of this chart. This is a roadmap of all your triangle congruence theorems that you need. And you really only need like 3 pieces of information to actually successfully prove that a triangle is congruent to one another. All right. What are some theorems that are no-nos? The first one spells a cuss word, I know. So that one is ASS. So I will actually draw a triangle that is marked ASS as kind of a warning sign here that you should not use ASS. If you have this type of scenario, you cannot prove that the triangle is congruent. And likewise, if you spell that word backwards, you can't either. And then another interesting thing is the AAA. And the reason why we can't do that, let's say we have like equilateral triangles. So you could actually draw, 2 equilateral triangles that are completely different in size. And that is why AAA does not work. All right. Another thing that we can do, we could have a situation where maybe you have 2 triangles. So I have like A, B, C and D, E, F. And I could actually think about proving these triangles congruent. Maybe I have like a side angle side. And after I prove them congruent, I mean, I could say that, you know, triangle ABC is congruent to triangle DEF. And then I could also even say that angle C is congruent to angle F because of CPCTC, which stands for corresponding parts of congruent triangles are congruent. So you are going to be seeing that in some of these proofs that we are going to be doing, not today, but tomorrow. All right, so just to kind of give you a preview of where we're going, and I would write this in your notes. This is kind of your roadmap of where we are going with proofs. You will be given information on your proofs, and then you need to be, you know, gathering some specific evidence, maybe about 2 or 3 pieces of evidence, you know, sides and angles. Sometimes they'll be, you know, practically given to you or marked in the diagram. Sometimes you may need to use something like vertical angles or reflexive property to get to where you need to go. And then you're going to use your triangle congruence theorem to show that the triangles are congruent. And then on some proofs, if they're asking you to prove that a particular side of a triangle is congruent or a particular angle, then we use, you know, CPCTC as our reason. So thank you very much for tuning in. Tomorrow, we will be moving into real delta math proofs, and there'll be a nice video with tips as to how the delta math proofs work. So thank you very much for checking in.